Greetings, math fans. All right, so this is day 6, and basically what we're doing on day 6 is, again, more variables, but now we're going to be multiplying terms with exponents. So, and then we're going to get to dividing. So let's just talk about multiplying. Multiplying with exponents. Okay, so let me just give you a basic problem here. If I said x squared times x to the third. Well, remember, if I wrote x squared, I can write that as x times x, right? X times x is x squared. And then x cubed, I can write as x times x times x. Well, how many x do I have? I have 5. So 1, 2, 3, 4, 5. And so our exponent is going to be x to the fifth. So what do you do to get from here without having to write all the x's out? Well, I mean, basically, you're looking at the exponents here, right? And what do you do with those exponents? You add them together. So when you multiply, this is important, when you multiply terms together, you add exponents. That's basically what you do, math fans. You add exponents, right? They have to be the same base. So in other words, x to the fifth times y to the third, you can't do anything with it. That's it. It's completely simplified. Okay? So be careful. A lot of times what kids want to do, if you have like x to the fifth times x to the fourth, they want to say that's x to the 20th. Boo! Okay, you don't, this is multiply. This is 5x written x, 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 and this is 4x is x, 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 x. And when you add them all together, you get 9 of those x's. You don't get 20 of them. Okay, so it's not x to the 20th, it's x to the 9th. All right, kind of the same thing if I did 2x to the 5th plus 7x to the 5th. Right? That's different. That's why I want to show you that. This is different. This is, if I have 2x to the 5th and I hand you 7 more x to the 5th, what do you have? You have 9x to the 5th. Okay, but when you multiply, like I did here, all right, when you multiply here, then you add the exponents. Very, very important. Okay? All right, it's kind of the same with numbers. Well, here, just again, another quick example here. If I said x to the 10th times x to the 7th is x to the 17th. Add the exponents. Okay? So I said it's same with numbers. So in other words, if I have 2 cubed times 2 squared, that's 2 to the 5th. All right, so once again, think about this. I mean, this is a mistake that kids make. They say, oh, 2 times 2 is 4 to the 5th power. That is not correct. Because think if I'd say 2 to the third, isn't that 2 times 2 times 2? And 2 squared is 2 times 2. So how many 2's do I have? I have 1, 2, 3, 4, 5. 2 to the 5th power. I don't have 4 to the 5th power. I have 2 to the 5th power. And of course, you can never leave it as 2 to the 5th power. You need to simplify it. And of course, 2 to the 5th power is 32. And that's your final answer. Okay? So please don't do this 4 to the 5th thing. When you multiply terms together with the same basis. And guys, this just real quickly, like if I said 2 to the 5th power, that 2 is called a base. Okay? And that is an exponent. All right? So just kind of keep terms kind of straight here. Okay? All right. So we got actually one more quick example here. If I had 2 squared times 3 squared, you can't do that together. You can't combine stuff together. You can't say the 2 and the 3 and put it together, because that's just like saying that. That's like saying right here the 2 and the 2 and putting it together and get 4. So you don't do that. So here's the deal. You can't do anything with this except simplify the 2 squared and the 3 squared. So the 2 squared is 4, the 3 squared is 9, and your answer is 36. Can't do anything special with that. Okay? All right, so let's keep going here. So let's do a couple other math problems now. We're multiplying things together. So if I do x to the negative third times x to the seventh, basically, again, you're adding these exponents. So you want to use your calculator, I don't care. You're basically saying negative 3 plus 7, which is 4. So the answer is x to the fourth. Okay? X to the negative eighth times x to the third. You add the exponents together. Negative 8 plus 3 is negative 5. So that means it's x to the negative 5, but you don't leave it that way. It's 1 over x to the fifth. Okay? No negative exponents. Very important. Okay? All right. So here, let's do it some with numbers here. 2 squared times 2 to the negative fifth. I'll add them together. 2 minus 5 is negative 3. So you really have 2 to the negative third power, which is 1 over 2 to the third power, which is 1/8. Okay, remember you just put this in your calculator, 2 to the third power, and then it's 1 over that. Okay, so far so good. 2 to the sixth times 2 to the negative 3. 6 minus 3 is 3. 2 cubed is 8. Oh yeah. Okay. It's not bad, right? All right, so let's do a little crazier problem here. 2 in parentheses, 2 squared, x to the seventh, y to the negative sixth, z cubed times 2 to the negative fifth power, x squared, x to the negative 2, sorry, y to the negative 3, z to the first power. It's got a lot of stuff in it, but we're going to only combine the stuff that's the same base. So like basically I have the 2 squared and the 2 to the negative fifth. So 2 minus 5 is negative 3. So 2 to the negative 3 power. X to the 7 times x to the negative 2. 7 minus 2 is 5. So x to the fifth power. Y to the negative 6, y to the negative third, that's y to the negative ninth. And z cubed, and z to the 1 is z to the fourth. Okay? So you move stuff that has negative exponent down to the denominator here, and we have x to the fifth, z to the fourth, that's positive, so that stays on top, and this 2 to the third, that goes in the bottom, and the y to the negative ninth, so y to the ninth, that goes in the bottom. Okay, only thing I have to do is simplify this guy right here, the 2 cubed. So it's basically x fifth, z to the fourth over 8y to the ninth. There's your answer. Okay, it's got a lot of stuff to it, but just got to be really careful and just do everything that I showed you guys in class, and you're good to go. All right. All right. Okay, so let's go on to division now. So division of exponents. If I give you guys x to the 10th over x cubed. So think logically. If multiplication, if I said x cubed times x to the 10th, you add the exponents, what do you think you do when you do division? Aha! You subtract. So it's basically you're doing 10 minus 3. You're always doing the top minus the bottom exponent. So 10 minus 3 is 7. So your answer is x to the 7th. Pretty easy, right? Okay. So let me show you kind of a little way that I learned back in the day from actually my very first year teaching at Lamont High School. And I kind of added on to it a little bit, but it's okay. I'm going to give a couple of teachers credit over there. So think of it as the Civil War. The Civil War was between the North and the South. So of course on top is the North and on the bottom is the South. And if you have a battle between the North and the South, and you look to say who wins, well, the one with the bigger army wins. So if you have x to the 10th over x cubed, who wins? The North wins by 7, so your answer is x to the 7th. Okay? So it's just a way to do it. Now you're like, well, so we can put here, we can do battle. which is the Civil War. I know some of you guys are saying, well, isn't it just easy to subtract? 10 minus 3 is easy. Yeah, but sometimes you get a problem like this. X cubed over x to the 7th. And what you have to do is if we do it the mathematical way, you're going to say 3 minus 7, which is negative 4. So, you got to deal with a negative. So it's your answer is x to the negative 4th. And then you rewrite that because you can't have a negative as an exponent. So it's 1 over x to the 4th, and that's your final answer. Okay? Now, if I did it just using the Civil War, I would say, well, I have a battle between the North and the South. Who wins? Well, the bottom wins by 4, right? So there it is. 1 over x to the 4th. Okay? So that's not too bad. So let's keep going here. If you have a negative exponent, so I want to teach you how to deal with a negative exponent. So first I'm going to show you guys how to do it mathematically. So remember, you always say top minus the bottom. So the top minus the bottom. Okay, don't forget it's a double negative because you always do minus and then it's whatever that value is, you put it in there. So it's basically, if you have a double negative, that's a plus. So negative 4 plus 6 is 2. So the answer to this problem is x squared. Okay, so I want to show you kind of a clever way to do it now. If you, it's hard to battle when you have negative exponents. Okay, so I look at the negative exponents. A negative exponent is a SPI. Negative exponent is a SPI. So before you have battle, this is pretty typical of a battle. Before you have a battle, you try to bring your SPIs home. Okay, so they do all the investigation and the research, and then you try to bring them home before you attack, because what happens if you attack while the SPIs are sitting in wherever you're attacking, right? They're going to get killed. They're going to get shot, and you don't want that to happen. Okay, so you want to send the SPIs home. All right. So let's take a look at this problem. The x to the negative 4th over x to the negative 6. So before I do anything, this guy's going here, going home there, and this one's going home there. So you really have x to the 6th on top and x to the 4th on the bottom. Now you have no negative exponents, so now we can do a battle. 6 minus 4 is 2, so the answer is x squared. Okay, so it's not bad. But negative exponents, SPIs, and again, we're going to say they go home before battle. They go home before battle. Okay? All right, so let's do a couple more here. If I did x to the negative 7th over x to the negative 3. Now again, you could do it mathematically. It's a little bit more work because you're basically saying negative 7 minus a negative 3. And that means plus here. And negative 7 plus 3 is negative 4. So that would be x to the negative 4, or 1 over x to the 4th. That's kind of a lot of steps. Let's do Civil War battle. Okay, the SPIs go home first, so you get x cubed on top and x to the 7th on the bottom. Now I do battle. Who wins? The bottom wins by how many? 4, right? So it's 1 over x to the 4th, and we're done with the problem. What? A lot easier. Civil War is easy. Okay? Let's do another one here. X to the negative 6 over x to the 4th. Okay? Well, the SPIs go home first, so this is going to go down. So it's 1 over x to the 6th, x to the 4th. And what if I combine those together? Which you can, so right, because they have the same base. So remember, when you're multiplying this down here, you're saying 6 plus 4. So it's really, the answer is 1 over x to the 10th. Okay, and then you're done. All right? It's not bad. Not bad. Nobody seems to be crying, though I really can't tell if they're crying or not. Okay. The numbers are the same as the variables, math fans. Okay? So, so I'll put here numbers are the same as variables. And basically, you need the same base. You need the same base. So if I gave you guys 2 to the 5th power over 2 to the 2nd power, they have the same base, I do battle. Who wins? The north wins by 3, so it's 2 to the 3rd. If you want to put over 1 to help you, but you don't usually put to the 1, over 1. And so 2 to the 3rd power is 2 times 2 is 4, times 2 is 8, and that's your answer to this problem. Okay? It's not too bad. Okay, so let's try another one here. If I give you 2 to the negative 4th over 2 squared. All right, so the first thing you do is you're going to move that guy down. You're going to move this down because it's pi, so it's going home. So it's 1 over 2 squared, 2 to the 4th power. Same bases, guys, so I'm allowed to do 1 over 2 to the 6th power. All right, almost done, because 1 over 2 to the 6th power is, well, first of all, you put 2 to the 6th power in your calculator, and you get 64. So your answer is 1 over 64. Okay? All right, so let's keep going here. Got a few more examples. 2 to the negative 8th over 2 to the negative 6. Send the spies home, man. So it's 2 to the 6th and 2 to the 8th. And then I do battle. Who wins? The bottom by 2. So 1 over 2 squared, because it wins by 2. And then 2 squared is 4, so the answer is 1/4. They're really pretty easy. They really are. Okay? How about this one? 2 to the 5th over 3 squared. Here's the deal, man. You can't subtract. You can't do subtract. You can't do battle. So can't do battle. Okay, because they're not the same terms. Not like bases, right? Because one's 2 and one's 3. So you can't do it. So you actually have to do it just separately. So 2 to the 5th power is 32. And 3 squared is 9. And that's it. That's as far as you can go. 32 ninths. Okay? Okay, so our last problem is a combo problem. So let's do that one. Combo. And like I said, it's got everything in it here. All right? So we're going to have 4 squared x cubed y to the negative 2 z to the negative 1 over 3 cubed x to the negative 6 y to the 6th and z to the negative 4. Okay, really not difficult. So a couple things here. Let's deal with that 4 squared. Isn't that 16? Oh yeah. And what about 3 cubed? Put it in your calculator. 3 times 3 times 3 is 27. Okay, that's cool. All right, so let's send the spies home. So that negative 6, x to the negative 6, it goes to the north. And so you got 3 armies here now. So now it has 12 armies. Or sorry, 9 armies, right? Okay, so 6 goes on top. You have 3 plus 6 is 9. Okay, this negative 2 goes to the bottom, so I have y to the 8th in the bottom, because basically it's adding 6 armies to the bottom. And the z's are just switching spots. So z to the 4th and z to the 1. Okay, the only thing I really need to do here now, math fans, is I need to battle the z's. That's all I have to do. So it's 16 x to the 9th z. If I battle these guys, do you guys agree that the north wins by 3? So z cubed. And the bottom is 27 y to the 8th. All right, and that's it. So, got to try the homework, guys. It's a lot of different types of, either multiplying or dividing. And you got numbers and you have variables. So make sure you guys are good to go with this stuff. All right? That's it, math fans. Have an outstanding day. Adios. Goodbye.